Hello viewer, this is my first documentary around any project that I've done in the last 5 years. First impression before going into the project is I'm not quite sure on what I should be doing. It's always time to take the effort. You never know if you do not try. Yeah. Now starting out, I could know quite possibly nothing about what I was going to do for the project, but it had to be something with an element of sophistication. Sophistication, yeah. The glasses aren't just for show, eh? So I decided to go for something that involved my teacher being my mentor, which was Mr. Zabudsky. Yeah. If you do not know, Mr. Zabudsky is the teacher of the drafting class, where computer-aided design is taught and other things like 3D printing, 3D modeling, uh, learning about mechanical mechanisms or engines or components of, complex machines. I'm going to be different. I'm going to set upon doing something with a different cliche, or with a cliche but just with my own touch. Alright, so I finally made the decision. I'm gonna settle for computer-aided design. I'm going to get very intricate and precise in what I'm going to do for computer-aided design. And the number of topics around a demographic of many other things, or a demographic of a variety of things, like house building, 3D modeling, AutoCAD, which is basically for 3D orthographic drawings. I'll get into much further detail later through this introduction, of course. Uh, yeah, but the next segment will be a full depth analysis on, trial and error on what I had, and I settled for something having to do with computer aided design, or a number of things having to do with computer aided design, to be exact. Seems like a complication, seems like it's going to be a confusion, but it shouldn't be a chore for me. A variety of programs in question will be made use of. First, starting with AutoCAD. Yeah, AutoCAD is a 2D drawing user interface, or a UI, which implements orthographic design and now just 2D drawings, for that matter, to create measurements behind schematics of objects, parts, mechanisms, like joints, whatever depth of imagination you want to be descriptive around. And yeah, it basically brings an object to a piece of paper. And the benefits of that is you can make anything you can possibly imagine. Anything that works, functions. If it functions on the piece of paper, if it's sensible to be on the piece of paper, then you have to use an orthographic CAD to create such things. After my AutoCAD revision, or just covering topics from the previous year, a year where I would say that I did not try that much, or even attempt to uh, do much with that. I am going to move on after this segment to AutoCAD Inventor, which is basically a 3D modeling UI where you can pretty much design whatever you feel like designing. Yeah. Through 3D modeling with Autodesk Inventor, I will learn a number of things involving how to customize and draw specific objects, and how to use certain functions to create shapes to real material objects. Of course, AutoCAD Inventor can also be used to bring these objects into the physical realm, uh, much doing this by 3D printing, of course. And that's one of the benefits of into AutoCAD Inventor. Yeah, it's very precise, very intricate, and it's very helpful. And it is expensive, yeah. It is. Okay, now third demographic or group we will be discussing is Autodesk Revit. I know Autodesk seems to be the theme, but shortly after I will be doing something around the company Yo-Yo Games. And by Yo-Yo Games, I mean Game Maker. But we'll get to that right after this segment. Yeah, basically for Revit, I'll show you the depth, the process, and what it took to create houses, all starting from the levels, from the 0 0 foundation up to the 0 1 first floor, to the 0 2 second floor, and to the 0 3 the roof. Basically, just starting from the ground up, building a house, something of modern design, something that is elegant. Yeah, I want to say elegant, just a basic model house, a modernistic house. Yeah. A key factor into building a house is personalization, in my opinion. Personalization depending on who the house is going to belong to, whether it matches or is compatible with your field of work, whether it is recreationally valid for your interests, things like that. I'll be teaching how to personalize a house based on things you prefer. Fourth demographic I will be getting into is Python script. I said I was going to do something with coding. Unfortunately, not C++ or C++. Python is actually a language used to make games, so I think one language is enough for a period of 2 months. I mean, I'm not going to go too crazy with it by, reaching into different languages. I know they're all one and the same fundamentally, but Python seems to be what I chose to start out at first back in grade 8, but I still wasn't that proficient back then. So I'll be going over scripts, basic ideas of Python, and how Python can be implemented into games. And I'll show you a game that I made, which is actually going to be the fifth demographic. Yeah, last but not least, I'll get into Game Maker and how to design a 2D RPG, whatever the type, like game like Mario, a game like a plane shooter game where you're supposed to shoot different obstacles to get through. What was that game called where you just like move the joystick and like the plane would just like fire and then you had to like shoot the objects, like games like those. I made the game like that, but a twist to it is that the plane actually moves. You can actually see it move to different locations. Alright, I'll be teaching you how to animate with that based on something quite similar to stop motion, but it's actually a compilement of different pictures to create a animation. You can obviously do this by creating your own pictures, but I will feed pictures for my animations. Alright, I hope you're ready. It's time for us to begin. I hope you really enjoy. Okay, now here's our segment into AutoCAD. This is the first program that will be my first step in the mastery of computer-aided design. AutoCAD is an orthographic drawer user interface mainly aimed towards beginners. This program is intentionally used because 3D modeling and AutoCAD share some of the same features as one another. And by features, I mean tools, functions, other sorts of descriptive properties are quite similar to one another to, formulate an object in some form or other. My first experience with the program was in my grade 12 drafting class. Because I was doing this program slowly and slowly mastering it, it influenced me heavily to make this capstone project. Around grade 11, I had no clue at all how to do anything. My final mark in that class was 50%. I chose to turn things around in grade 12. One thing that I was previously terrible at was 2D, 3D sketches, which intentionally made what is a 2D sketch appear 3D. Long tries of practice got me there eventually. The benefit of 3D sketching is that we can formulate what an object is going to look like in a real 3D perspective. 3D is sort of hard to master at first because the physics are so new to us. When we draw something on a piece of paper, we usually draw it in a 2D perspective, like words. Unless you've been growing up drawing cubicle words or bubble letters since your childhood, you might find something like this very difficult, and I did. I had no clue how to dimension at all, and what the function actually served as. Dimensions are basically written and indicated places that mark measurement in the appropriate unit. So, say you have a measurement going west 100 units. A dimension will indicate that you went west 100 units, and on a real-life object, that line which creates the border from nothingness and what is matter, you can indicate, or you can find out the measurement of that just by looking at the piece of paper and not actually having to use measurement instruments to do so. I learned after trial and error and seriousness, I learned all the controls I needed to know. By looking for sources over the internet, I only looked over at the smart kids' computers only a couple times. I'm very persistent in completing and achieving perfection. In almost everything that I do, I realize that this discipline was my undying desire that I had been neglecting for years. Going about AutoCAD is going to be a journey. Well, more like a trip of nostalgia. Through exercising, I went learning through tangents, which is basically connecting circles from the outside by a straight line. This can give shape to joints, other things, manifolds, just a couple of objects of reference where drawing tangents can be very useful. I learned to manipulate and create intersections between lines that had crossed. I finally felt like I was going to get about done until I had an assignment returned to me with a 7 out of 10. This honestly disappointed me. I did not expect to get such a garbage mark. I had messed up on the dimensions because I resorted to the same foolery I had done back in grade 11. Sometimes I just have bad habits, and that came to realization to me. I needed fixing and more useful ways to polish my skills so that I may go forth and accomplish. 3D drawing took a while, but I ended successful. If I could go back in time and tell myself one thing that would benefit me greatly, I would tell myself to look for online video tutorials. Watching a second lesson on the same subject can be very helpful. It can also feel like you've been sat in class twice, and it can have the same benefits as sitting in class twice. Tutorials can greatly enhance one's speed of learning, and it has affected me very, very positively. I can find truckloads of content surrounding the topics that I would like to learn. Though that may be a vulgar analogy, it's definitely accurate. Reflecting on the whole experience, I wish I was more in tune with my learning of this program in grade 11. Now that I am doing it over in grade 12, I have slight dissatisfaction. Things that I hope to improve in are my dimensioning skills in more professional formats. The measurements calculated to perfection. Example, font sizes of symbols, style of lines, style of arrows pointing to dimensions. Those things need to be worked on a little bit more, because the end goal is an exemplary skill set, an exemplary mastery. Now, starting out in grade 11 drafting, we were given small quizzes to assess capabilities of being able to grasp the physics required to proceed and be effective throughout the learning process of CAD. We proceeded to create standard template, or a size A template, a sort of beginning obstacle so that the details can be enhanced in the drawing. It's basically setting up your own tool desk, you can say, like which screwdrivers you can have, which measurement capabilities are you going to place, standard stuff. We also had custom lines with their own colors, with their own thickness, with their own style. These are supposed to represent the of a lead pencil. Different line sizes represent different line widths. And the benefit of this is that it brings life to drawings that would be normally casted onto paper. Basically an online paperback drawing. Yeah. An exercise booklet was given out with drawings we had to replicate from a beginner noob level all the way to cutting edges works of art. We started out with simple circle combinations to create things like joints in a mechanical machine. These drawings were easy enough. We had no fillets or anything like that. A fillet is basically rounding an edge based on a radius, and to find the radius can be a brain tease. We measure in radius and diameters for circles. After the segment on the circles, we learn linear drawings and how to go about doing things like that. Center marks were also of inherent importance when making circles and dimensioning them. The tool in AutoCAD that I had most trouble with was the fillet tool. You could remember how it worked, but you always forget it, as I mentioned earlier. The most important thing to grasp from the program after learning it for a while is creative intelligence, and now received freedom to depict such things. Say, for example, you have an ideal object you wish to prove on a piece of paper. One can go about drawing it and deciding its measurements, then later transferring it to a piece of paper that will be a depiction of a finished product. The benefit of this program is that you can draw instructions for it, and you are later able to recreate it. The thing with having the product in 3D is the incapability for info on the object to be accessible efficiently. Going about an object with an orthographic perspective is the apex of procedure when designing something state-of-the-art and professional. After months of practicing this program, I can nearly draw anything, based on a reasonable schematic, of course. With a literal amount of time, I could hold physical objects in my hand and draw them on the program. Now that I have a membership, I will definitely make use of this program more and more with academic purpose. To summarize all that I've learned, it was all the things that I had neglected to learn in grade 11. From the filler function, which is used to create curves, copy function, which is used to minimize work, offset command to further minimize work, the dimensioning and how perfect and simple balance of dimensions can create the most efficient and effective schematic. Learning all that contributed greatly to my knowledge of orthographic drawings. And yes, that's pretty much it for the AutoCAD segment. It was a long and hard journey. Lots of things I had to relearn, lots of things I didn't understand and still couldn't understand coming back to it. Yeah, that's all I have to share. Next segment, Autodesk Inventor. Thank you very much. Introductory to Inventor. Quarter 2 drafting class is where it all began. I had just by chance finished all my assignments faster than anyone in the class and was left with nothing else to do but to relieve my curiosity about learning 3D modeling and what that would look like. I was given instructions specifically to use a custom online course provided by Mr. Zabudsky to introduce and improve my skills. I spent the entire class doing 3D, the first day that I had begun. The first section of the course had an outline from 1 to 10. The first object was simple enough. It required me to open a sketch on the X-plane, which is basically a central flat area where I can extrude a sketch to get pulled up vertically. By completing these steps, I was left with a uniform square that served no inherent purpose. Before completing a first object, I had to design and set up a template to build off of. I used a metrics template with the measurements in millimeters. Adjusting the settings to the current country that you are living in is very important. The metric systems of unit measurement is quite possibly the greatest unit of measurement on the face of the planet. Going about creating the shape of an object is one thing, but then you will have to decide the material that will have to be used when manufacturing a product. This user interface allows you to use a wide range of variety of different substances. The added creativity is further increased by the addition of this feature. The next thing that we did after doing the personalization with the object was then to add further detail to one can add to an object. We had learned how to de-extrude designs onto an object. We did this by using the extrusion menu and then adding a measurement to then cut the design on the object. By cutting the object, we added an instance where the portion was removed to then serve a purpose of giving a shape to an object which was once basic. The design entirely depends on the sketch that you have to make on the surface of the object. If you draw a circle, you can de-extrude a circle. If you draw a triangle, you can de-extrude a triangle. Now this sounds pretty complex, but it is yet to get increased in complexity. Dimensioning is a very important tool and is key in creating accuracy in alignment. Without dimensioning, an object is hypothetically made but never will be legitimate. Dimensioning is a function that allows one to place a measurement on a sketch in proportion to or any personalization varying on the point of objects you classify as the origin. Dimensioning is a concept that is mandatory to all who use the program because drawing and modeling cannot be made in proper attempt without doing so. You can also learn that if you download models off from the internet, you can deconstruct the way that it had been made and implement the techniques that have been used so you can gradually make more and more sophisticated models. I tried to download parts of the internet and I learned more and more as I progressed through the learning process. The extrusion method is a sophisticated and useful method when bringing an object into reality. The instance is simple and so easy and calculated to use. One can extrude any shape that he likes by doing so. Another useful tool that I learned was the workplane tool. Usually one would have to sketch on the surface of an object to create changes or edits or anything like that. A workplane allows one to add a sheet to sketch anywhere he wants and add objects wherever he wants. The workplane feature also allows one to create an extrusion parallel to any object, and you can also adjust a workplane angle wherever one would like to do so. I use a workplane tool to create a number of objects. The revolve tool, I personally love this tool very much because the capabilities with it are truly endless. You can design cool things at first. I was very hyped to know the things that I could do with this. This basically allows you to create a 3D radius and circumference of any object. Say if you draw a rectangle, then by using this tool you will have a circular rectangle in 3D shape. It's basically like the extrusion tool, but it gives circular life. You could do it vertically or horizontally. You could turn the rectangle into a disc like object. if you do it horizontally. If you do it vertically, you'll get a rod. Constraints is the next topic that is of discussion. It allows one to put objects together such as hinges, or two objects that are meant to be fitted together. This function serves as a purpose that can formulate technology. Say if you have a pen case, or like a casket that like slides in, like two wood pieces that slide in to close a case of some sort. You can use a constraint method to put two objects together and add your own custom physics to the object. You can also create different types of machines with this. You can also simulate gears in a turning machine and a watch, or you can just do things out of interest. The excitement I felt after gaining this information was real, and yet I thought about how I wasn't even scratching the surface. And that was pretty much it in my 3D modeling journey. I learned most of what I needed to learn, but I've yet to expand on a professional level. Alright. Segment is Revit Home Design 2021. I began this project as a more in-depth perspective to see how making a house can look like, and to see how other factors like foundation play and role placement of a house. This project began as a fascination to see the line of work behind architects and what they do and play behind. Believe it or not, I have a cousin who designs apartments with complex computer-aided design, and at first glance it was something that I thought I would be really interested in. And yeah, it's kinda true now, I guess. I have an extreme fascination with large-scale tall buildings like skyscrapers and such. Every time I go downtown, I wonder what life would be like if I was among the organisms who have one of these buildings to themselves. Kinda hit me like an epiphany back then. And yeah, I think I'd like to design buildings, but at the time I have, maybe not this month. Now it's time to begin with Revit. Revit is a user interface that allows anyone to build their own home from the ground up with ease. Revit is an architectural-based program that shares its orthographic perspective as well as its 3D perspective. Revit is more or less known for its 3D generation. Yeah, it's not bad. The user interface is actually really easy to manipulate and work around. You can personalize location, time. As you can see right here, location, time. You see our longitude and latitude. I believe we are in Columbia, Massachusetts. Yeah, and the date is June 21st. You can design almost anything like that. Landscapes as well. You can, I'm on a slope here. Yeah, this can give you a deep contemplation, in-depth constructively on how to improve your model based on where you are in the world. I began to go about this by viewing tutorials on the internet explaining in bits and details how to build a house from scratch. I began by adding levels from foundation 01 all the way to 04, which is the roof, and I'll show you that right now. So yeah, so foundation here, and I added all the way to 03 to the roof, not 04, 03. The next step was to add some concrete standard walls. This step was by far the most confusing, and I did that on 01. I basically just added walls around using the wall function right over here, and you can design the offset preferably to whatever you want it to be. Yeah, but at this point something was missing. I needed a landscape of a sort, and what I did, I used the camera function. I went to structure, no, yeah, precast system as well. I basically used a camera function of a sort, see if I can find it. A lot of tools to keep track of. I was on 2018 before. Yeah, I used this function right over here to create the slope that I have now in 3D mode, which is this one. Use this function right over here. It's actually not that easy. It's pretty easy. Quick Google search will get you there. And I use view actually to get the camera angle to create what is known as the landscape right now. And to get the camera angle, you have to click 3D view and click camera, and then you have to go to foundation folder 1, and then no, get the camera out. Well, you take a picture, and then that's what you get, and the camera you can adjust and stuff to see what the house would look like on the ground, which is very insightful. That looks cool, doesn't it? Yeah. You see like the underpass, the balcony right over here. Things like that. There's lots of stuff you can play around with, and you can raise this up, see what it looks like. We'll see what the low roof looks like from a lower angle. That's beautiful, isn't it? I wish we could get this in color. Maybe we'll see it in Revit 2023. And yeah, you can basically see the camera angle of the house. 3D views. Yeah, a lot of stuff like that. I'm just gonna delete this. I don't need it. And next one. I had to complete the shelter, so I went to the roof function and placed the roof as a standard for weathering protection. So basically, I went to the roof function, and I went to architecture, and I clicked the roof function, and I spread out a surface area of mass based on measurements that I had gotten from somewhere. And yeah, I created my roof, and I also had to slope it, which was something. I don't remember how I sloped it. Did I ramp it? Yeah, there was a slope function somewhere where I was able to slope it, but I'll get right back to that. Yeah, and I also had to place a floor on each surface, and I did floor by just using the floor command right over here. Can place structural floors, architectural floors, anything like that, and you just like make a line around, select the inner area with left click, and then you can put in the floor. You have to do it for every level. Yeah, I angled my roof, and then I had to extend all the walls. I actually did this in 3D view. I just selected all the walls one by one, like this. Selected all of them one by one. I think I held shift as I did it. Yeah, but I selected all the walls, and then I did attach top base right over here. And it attached to the roof. And yeah, the house started to look more and more like a hospital place. I added windows and such right over here. These are custom windows that I had gotten online. I had to download the templates for them. And I used different doors for different entrances. See, there's a door here, there's a different door right over here. Different doors for different places, and there's also individual rooms with their own different doors as well. Balcony railings. Railings was the hardest part because the program would keep crashing, but I got some nice glass railings, a really modern aesthetic to it. Yeah. And yeah, after completing this house, I could only contemplate many of the possibilities. I think I'll start to get into building real buildings soon. Like, I want to do that. I think I'll get into that. Maybe if I pull my schedule around, I'll probably get to it. Alright, so this is all I have for Revit home design. It was a large project, and you guys get to see everything that I did. And stuff's really not as hard as you think it is. It's just Google searches. You can replicate the exact same thing based on the instructions that I've given you and all these perspectives that I've given you. And I'll just show you what it looks like on each level. Here's the level right over here. I just did walls on the inside. It's literally as simple as putting walls on the inside and just getting your own wall. You can learn how to get your own types of walls. You can actually, if you click on the wall command, right, you can actually change the type of wall you have. You can get storefront walls. These are glass walls over here. You can get interior walls, 5x1, 2, generic walls, masonry walls, brick walls. You can do anything you want. And yeah, I could only contemplate the possibilities that I have with this program. More things I can do. Oh yeah, to place the top surface command, you have to go into site. And this is what I placed. I just basically, dragged out the top surface, selected it, and then increased elevations in certain areas with the top surface command. It's really a Google search away just to learn how to do that. You'll learn it under 30 seconds. Alright. Well, this is it for Revit. Yeah. Hello, here's my introduction to Python scripts. Python is quite simple, so I'll give you the basic rundown on some Python scripts that I made. Okay, maybe not that one. I'll show you how this one works first. Okay. I'll show you how the dice one works first. Okay, so import random, basically importing your source, basically starting it with Python. While true, at the beginning it will tell you to print you would tell the computer to print this in general, press enter to start, and basically this function right over here creates random selection from 1 to 6 based on an algorithm that is located within this command right over here, and whatever I place underneath it are the possibilities of the variables. 1 to 6, these are the variables, and per variable it will print what is over here. So each variable contains what is over here. Variables are a way to reduce excessive coding, and they have great importance in the coding world, you can say. So basically, this is a rolling die game. Press enter to start. I click enter. Oh no, shouldn't have done that. All right, click enter. All right, I got a 6. Click enter again. I got a 4. Click enter again. 5, 3, 2, 5, 2, 3, 5, 5, 2, 6, 6, 1, 1, 3. It changes every time. This is just a basic rundown of the basic Python script. I'm going to show you a Python game after this one. Here's another Python file that I created. It was just a simple drawing that was left unfinished because repetitive nature is just, it's torture, so I didn't want to finish it, but I'll show you what it looks like. Basically, turtle who makes a cake, but it messes up a little bit. Oh no. You're not bad at all, isn't it? Yeah. Made a nice little cake there. Yeah, you can also get it to draw things as well. This is quite literally a basic one. So you can also do this with Python as well. Is this game right over here. This is entirely made with Python. It's just a simple game anybody can make in less than a week.
I'll show you a quick rundown of the game.
Whoever made it had very poor taste, in my opinion. Especially you can use your mouse to control this hammer thing. And when you fall, it resets. Yeah, a fellow classmate made this. I don't know how deranged he was, but man, the guy had problems. Okay, I'm not playing this. This is not worth to melt my brain over. I have the rest of the night to complete this capstone project. Okay, I'm done here. This segment is called Game Maker. I'm just gonna open up a couple files for you guys. Game Maker info. This was my first game that I've ever made. It's called My Game Maze. This game I made a lot. Yeah, these are all the sprites I used from my game. These are all custom made. This one's custom made. You can basically make a sprite by creating a sprite, edit a sprite, and you can draw one right here. Animation. Oh, you can also do all sorts of animations here as well. So if you have like multiple animation, you can do Game Maker explosion animation. Right there. You get images, and look, this animation's right for you over here. And you can just attach grids, which is like boxes, and it creates its own like stop motion, and you can make animations for games, which is really cool. Here's another one. No, that's actually something else, but you can make this. Here's some more animations. You can make an atomic bomb animation, which is basically like I can do a lot of stuff. Here is some other animations for like shooter games where like these are like pixelated explosions. There's so many different grids. I mean, there's so many different possibilities. Yeah, so basically you can add animations there and transform images, and you can create a new one. Okay, sure. Here's the image. Now you can draw whatever you want. Say I want a smiley face. There you go. I got a new sprite, and I'll show you what a sprite does in a minute. Okay, sprite 16. I don't want that. Alright, whatever. And here's some sounds. You can just get those from wherever you'd like. It's the background I use for the game. Normal background. I got that from somewhere. This is the other background I use. It's a little SpongeBob thing. I do not own any of the images. And I'll show you what it looks like when it runs. Alright, this is what it looks like. Here we go. Click on it. Nice, I dodged it. And look, the block that's moving is me. You basically have to dodge these guys and get to the key. It's really hard to do. It's really confusing. You have to see where the key is. I can't find the key because everything's moving around so irate. And yeah, I'm just gonna head towards the key. I got the key. Alright, see me in the corner right here. And I head back down. I'm just gonna show you how the functions enact and become the way it is. And I have to get to the exit, which is the lock. That's right over here. I got the key and now I get the lock. I don't know, this game was harder before. And now it says game over. Pretty good game. And here are the rooms that I use for it. Room 1. I basically designed the entire room by using the block right here. This is a custom made block, not really anything original. And how do I get rid of that? Got the snap-on 32 by 32. It's basically simple room, and you can add in backgrounds here, tiles, settings, objects. OBJ boss, I can add in one of these if I want. A wall, add more obstacles, whatever I want. See, this place right here. I'm just gonna delete that. And I'm just gonna show you the sprites. Alright, collision, checking, modify mask. I'm going to show you the other stuff, scripts. I have scripts. I wasn't that descriptive with the way. Yep. Now we can just head into objects and you can see each and every one of the variables each object has. This wall just serves one purpose, is to keep this player away. And I added a collision with the wall and a collision with the lock. And upon collision with the lock, a variable is released. Variable is has keys equal to 1, start a block and destroy the instance, and then it goes to room 2, which is actually the game over thing. And the key, it's a variable as soon as you touch it, and it destroys the instance as soon as you pick up the key, and it remembers it. It gives you the variable as well, and this one, it has to equal to this variable to be, yeah. If you get touched by the guard, you get jumped to the first position. Same with the boss. And left, start moving in a direction. Left basically indicates the arrows on your keyboard. You can see what direction it is. Down. Yeah. It's basically, this one tells you to stop. See? Yeah. When you release any key. So everything has to be designed. Let's see. You can see more commands. OG wall, bounce against solid objects, which means this guy cannot pass through the wall. He just bounces right off, which is why you see him going up and down. OBJ burger, I never got to use this one. It's a good sprite. I'm going to use that for another project. Okay, that one was pretty good. I'll show you the next one. This game's going to be good. Nice. This is the game that I made. Very good game. It's a plane shooter game. Oops. My bad. Alright, recording at 60 FPS. Let's go. I'm in full concentration mode. This game is so hard to play. I've got to get out of this corner. Okay, the game lagged, but I almost... Alright, let's see what's in the game. Sprites. Alright, we have SPR Island. Just a normal island. Get up. Island over here. You guys already know what sprites is. You just add them to objects and you can set all the functionalities. This is a spaceship. These are the bullets. SPR die. I believe this is what it looks like when you die. And this is the animation of the explosion that I made. And if you click into edit, you can see it's the entire animation. It's really high quality because the more the pictures, the more defined the explosion looks. Clouds, explosion number 2. This is for the mothership. As you can see. Yeah, nice stuff. It's all free on the internet, so anybody can really make an interesting game. These are just sounds that I use. Explosion. I don't know if you can hear this or not. Yeah. Okay, so here are some of the commands. I'm just going to go through them. You probably already know what these mean. Just variables. Change instance into explosion upon collision. Space. Shoot if equals to 1. Start of the block create instance. Object bullet. Set variable. Shoot to 0. And this is just for ship. And if we go to bullets, you can see what the bullets are capable of doing. Step. Smaller than destroy the instance. Set the vertical speed. What I set it to 8. Nice. And this, obviously, you can see a lot of mothership. I'll show you what the mothership is. How many hits it takes. Set variable boss slicer to 50. So each bullet gets rid of a boss life. That's what makes this game exceptionally difficult to master. But if you guys heard about RuneScape, it was made on the same program as this one. I'm not going to make like a MMO RPG because I don't have that sort of hard drive space. I don't think I can make that on an SSD laptop. But yeah, here's a full game and you can see the rooms that I made. Here's level 1, 2, this is all the setups I put it in, and then spaceships just automatically generate from an instance that I made. And this is what it looks like at the end of the game when you beat the mothership. This is the lucky screen. That's what your 4 hours of non-stop practice will amount to. So I just let you in on that. You might have never seen that. You just wonder about the game, but you would have seen that. So I showed y'all. Alright, that's pretty much it for Game Maker. It was long and hard and difficult to make. I have more games I could show you, but I don't want to make the presentation too long. So, discussing everything, we went from AutoCAD to Inventor to Revit to Python scripts using the Thonny program and Game Maker. In Game Maker, we covered animations in the simplest forms. We could not get to Unity because 4-month duration, 4.5-month duration is not enough time for that. Unity is going to take much more because I need to know C# to implement physics in Unity and a bunch of lessons. But what you can grasp from this is that I also learned another form of computer-aided design. I learned how to use Photoshop and Premiere Pro. I'm going to show you guys what I do on Premiere Pro. Let's open this up. And edits that I've already made. This is also a form of computer-aided design. Just gonna, yeah, I basically have like a bunch of projects. Like learning Premiere Pro is also a computer-aided design project of its own. And I can also show you a thing that I made on Photoshop. It's also other computer-aided design thing. I learned this all in the duration of 4 months. Even the Adobe stuff, but you don't want to see that. So I basically made this image right over here. I made a lot of edits. That's just my face or something. Yeah. Learned a lot of stuff, but I cannot cover it. It's going to take way too much time. But I hope you enjoyed my presentation. This took a very long time to make, especially with my schedule. Physics 12, working 6 days a week. I'm surprised I pulled it off. Alright, thank you for tuning into my capstone presentation. This is what I covered and learned. If you want to implement these things yourself, school resources are available. It's just so you could, do these things. So this has been my journey through computer-aided design. It's going to be like a 50-minute video, but I hope it's worth it. Alright, I'll see you later.